Alright, so we're going to look at today inequalities. So that is our title.
Equality involved. Oh, it's inequalities.
It's on the second. Right, we're going to write down. When we have two expressions which are equal to each other, it's called an equation. You should all know that. And when one side of an equation is greater than or equal to the other side, it is called an inequality. So it's unequal. It's not equal. One side is not equal to the other side. So let's see if we can remember what these things mean. So, yeah. So we're going to write in words what the following things mean. Yeah.
Did you purposely write when one side equation is greater than or equal to?
Yeah. Greater than or equal to the other side. So if you're a bit unsure, then hopefully these examples will make that clear. Okay. You can tell me what this first one is, John?
X is greater than or equal to 3.
Good. So the first one is x is yeah.
What's the thing on the side that says X can be?
I'll talk about that now. What particular values could x be?
3.
All right, it could be 3, it could be 4, it could be 5. How do I show that this goes on forever? Dot, dot, dot. Could x be 3.5?
Yeah.
Yep. Could x
Greater
be
than.
could x be negative 4? Nope. Could x be 4.6?
Yep.
Right. Could x be the square root of 24?
Great.
Then what?
That you're being taken on purpose.
Yes. Could x be the square root of 24?
No.
Liam's getting his calculator out, which is a good sign.
Yes. Yes. Yes.
Why?
Mental math.
Hmm?
Mental math.
Why?
Yeah.
Because you know that it's 4 point something.
Well, you know that it's 4 point something good, Damon, okay? It is.
And that's greater than 3, which is the lowest number.
Excellent,
Because
right, good. Okay, nice, okay. Using your mental math. Just out of interest, okay, just out of interest, you don't need to write this bit down over here. I'm gonna, oi, listening. Just out of interest, these numbers, so 3, we said about the square root of 24, we said, 3.5. These numbers are all in the set of which numbers? Do you remember? You may have done it last year.
Is it that thing with the circle?
Like real and.
You're right, John. Yep, they are all real numbers, okay? That is an R, okay? It just means it's any number, okay?
Oh.
So, well, it's not just any number, but it's any real numbers. The numbers that we're concerned with are real numbers, okay? So we could actually be even smarty here and say that x. Does anybody know what that symbol means?
Yeah.
Is what does it look like?
A zero sign.
It looks like
Yeah.
Did he draw
Looks
it
like
out
an
properly?
Looks like
Yeah.
an arrow.
listening. So it is. I'll redraw it. Okay. It's kind of like an E. Okay. But what it means is x is an element of R, which is the real numbers. Okay.
You have to know this.
Isn't that IR? Yeah, you remember X?
It's not hard.
I remember X,
Yep. So x is an element of the real numbers. So all of these, but it must be greater than 3. Okay. So this is why I can take 3, 4, 5, and so on. But we'll not worry about this now. This one. What does this one mean? Somebody else? Liam?
Y is less than 7.
Okay, good. Y is less than 7. Why is it not less than or equal to?
There's no line under the
Because there's no line underneath it. So give me values that it could be. Preston?
6543 dot dot dot.
Yes, it could be 6, 5, 4. Anything
Well,
lower
I
than 7.
chose one.
This one?
So
Somebody read this out. Hans, Damon?
X is greater than. No, sorry. X is less than
Right.
1.
X is less than.
Negative 1. Negative 1 is greater than.
Yep, or negative 1 is greater than x. Okay? If x is less than negative 1, give me.
748.
Could be negative 1. Go keep
Thanks,
going. Ian?
I was going to say negative 2.
Yep.
Negative
Negative
3.5.
And so on. Okay? Alright, good. Can somebody tell me what this is a different way other than x is greater than or equal to 3? How else could I say this? Delia?
Oh, you could say 3 is less than or equal to x.
Right, 3 is less than or equal to x. That's another way of saying it. Somebody tell me another way to say this one. 7 is greater than y. Right, good. Okay.
This one can ask.
Yeah.
So this says x is less than -1. Shouldn't it not be -1?
Yes. Sorry. Yeah.
which way
My bad. Has to start at -2 because it's less than. It's not less than or equal to. That's my mistake. Thank you, Delia, for pointing that out. Okay. All right, so new heading. Okay, and it's going to be
I've never do any of this work. No, I don't work like this.
solving inequalities.
Yeah, design work.
Okay, we're getting all this time?
Yeah.
Solving inequalities.
Did you fly any kites over the weekend?
All right, solve for x. Okay, we're going to work through this together, okay? Because obviously, as always, there is a way that I want you to set it out.
When?
It's not too difficult.
Yeah, this is the first step.
Brand new whip got no keys.
Way harder.
Okay. The thing that I want us to realize is this is not really that much different. Well, it's not any different to solving a normal equation, okay? Except that this sign is different, okay? So if I was going to solve the equation 3x minus 2 is equal to 6, what would be the first thing that I would do? Hands up. Hands up. Delia.
+2.
I would add 2 to both sides. Okay, that would
Oh,
give me
smooth.
what on the left-hand side?
Yes.
3x. What would it give me on the right-hand side?
8.
6 plus 2 is 8. What would I do next then? Hands up. Hands up. Come on, it's always the same people.
I know, I'm just writing things down.
Ian.
You show Ian? Yeah. You got it? Yep. Divide by 3 on that side and divide by 2 on the other side.
Yeah,
Right,
Dave.
good. What you do to one side, you do to the other. So that leaves us with x equals, answer,
8/3.
8 over 3.
8.
Which is roughly what?
2 and
Well, actually, tell me what it is exactly.
2 2/3.
2. Okay, Grayson.
2 and 2/3.
You're
Okay.
right.
What is that?
You are so
What is that as a decimal? 2 point?
2.23. No.
2.2. Yeah.
2.7.
2.7.
2.75.
2.66.
2.6.
Recurring,
Six.
okay.
Yeah.
666.
Wait, what? Oh, because the 2, yeah, no matter.
Right, now listen.
I get it.
Listening. Gentlemen. Okay, if it is an inequality, we'd go about it exactly the same way. Okay, we add 2 to both sides. We have 3x is greater than 8. We divide then both sides by 3. And we get x is greater than 8 over 3.
Wait, so why? Wait, then why do we have to have this little? The greater than.
Just to confuse you.
Yeah, why?
Because you're solving inequalities.
Oh, just to make you mad.
Where would I find this in real life?
Where would you?
You would actually use this,
We are in.
but we'll come to real life examples shortly. Now, what values of x then? So, what could x be? X could.
It could be anything.
No, it couldn't be anything.
Oh, wait,
It
never
would
mind.
be 1.
No, I'm saying in general.
No.
It would be 2.
Right. Let's listen. Let's look. X is greater than 8 over 3, which means x is greater than 2 and 2/3. So,
Oh.
what values?
3.
It could be 3.
It could be 2 and 2 and 3. 2.
It could be
That would be 3.
2.9. It could
2
be
and
2.7.
2 and 3/3.
Okay, as long as it is bigger than 2 and 2/3. Okay.
2 and 3/3.
Does that make sense?
Yeah.
Okay.
Yeah.
Yep.
So x takes multiple answers. Okay. So when you're solving an inequality, you get you're getting multiple answers out. Okay. As opposed to when you solve an equation, you get one answer out. It's not any different really to solving an equation. However, things get a little bit strange if you have one like this. Let's okay. So let's work through this together. What's the first step in this one?
Plus minus 4.
Okay, I mean minus 4 from both sides.
That leaves you with 2x, negative 2x.
Okay, everybody just put your pens down for a second.
I'm just
Everybody put your pens down for a second because I want us to watch this because this is important. Ian, can you pay attention?
Yeah.
Here. Alright, so I've got x is less than or equal to, what's 18 take away 4?
14.
14, right. What's our next step?
Divide by negative 2.
Okay, divide, Liam, stop.
Yeah.
Divide by negative 2. Oops. And I'm going to divide by negative 2 over here. So when I do that, what do I get on this side?
X.
X. And on this side I get what?
Negative 7.
I get negative 7. Now at this point we need to be careful, okay? Because let's look at I haven't finished this for a reason, okay? Let's look at an example. Let's say 5 is, give me a number that 5 is greater than.
17.
5 is not greater than 7.
John.
Right, 5 is greater than 2.
One
okay.
job.
Now, I'm going to, okay, is everybody okay with this?
Yes.
Ian, can you stop writing?
Please.
I'm going to divide both sides by negative 1, okay? And I can do that because what I do to one side, I do to the other. yeah?
Other.
So what's 5 divided by negative 1?
Negative 5.
Right. What's 2 divided by negative 1?
Negative 2.
Right.
We've got the negative sign.
Thank you.
I said it.
Right there. Yeah.
Right. Now, is that still true?
No.
No, because we all know that negative 2 is
Greater
than. So,
greater than,
when you multiply or divide by a negative number, what must you do?
You reverse it.
You change the sign, right. Okay, so we're just going to make a little note here.
No.
And you divide by a negative. You must change or reverse that to the sign, and you can copy that down now. Right, here are 9 questions I want you to work through, okay? I want you to set them out. I've set them out in the examples, okay? And I'll come around and give you a hand if needs be, or we'll do a couple on the board as well, okay? Let's just record this. If I add 3 over 2x to both sides, that means that it gets rid of the negative part on this side. Okay, so it cancels it out. So I end up with, on the left-hand side, just a 1. On the right-hand side, I have 1x plus 3 over 2x. What's that going to be? You can use a calculator. Come on.
Oh, 1.5.
Come on, man.
Nope. 1 plus 3 over 2.
Oh, 2.5.
2.5. What's that as a fraction?
1 and 3 over 2.
Okay, look, I've got 1 plus.
Or 2
The
and
fraction was
2 over, or 3 over 2.
3 over 2.
I said
3
over a moment.
over 2. That gives me 5 over 2. So I end up with 5 over 2x, take away 4. At this point, what do I do?
You can plus 4.
Plus 4.
Add 4 to both sides, good. So on the left-hand side, I end up with 1 plus 4, which is 5.
It's greater than or equal
It's
to
greater than or equal to 5 over 2x. Now, how do I get rid of the 5 over 2 here?
multiply.
Okay, so there's different ways you could do it. Can you be more specific, John? Yeah, Eliza?
You put that bracket around it, so it's like multiply.
Okay, well the 5 over 2 is multiplying the x, so to get rid of it,
Oh.
I can divide by 5 over 2.
Not expecting that.
Okay, that's one particular way you could do it. So I end up with, on this side, the x. On the other side, I can use my calculator. I've got 5 divided by 5 over 2. Okay, you can use your calculator, make sure you know how to use it. And I get 2i. So let's write it as x is,
Great.
yep, greater than or equal to 2. That's one way. I want to just show you the other way because some of you might prefer this. No. These two things are exactly the same, okay?
Oh, right.
I've got x is greater than or equal to 2. X is greater than or equal to 2. I was just putting the x first. Okay, this next way involves getting rid of this fraction. Some of you might prefer this. If I want to get rid of the fraction on the bottom, what do I have to multiply by? 2.
3.
Yeah, I have to multiply the 2, multiply by the number on the bottom. So if I multiply this by 2, I have to multiply everything by 2 then. Okay? So if I do that, 1 times 2 is? Minus, this becomes just, 3x, because it's getting rid of the 2 on the bottom.
Ah.
Greater than is less than or equal to?
Yeah.
Take away? Right. Okay, now this is down to, there's no fractions now. I've gotten rid of them. I can add 3x to both sides. So I end up with 2 is less than or equal to 5x take away 8. Add on 8 now to both sides. So I end up with 10 is less than or equal to 5x. Yep, divide by 5. I end up with 2 is less than or equal to x. Some people prefer this way because it gets rid of the fraction straight off, okay? But you have to remember, you multiply everything by the denominator, okay?